Hi everyone, this is Mrs. J. Today we're going to learn about properties of radicals, but first please pause the video for this quick warm-up. All right, go ahead and check your work here. So for this one, I wanted a quick review on rewriting rational exponents as radicals and then simplifying, but also I wanted to point out how important parentheses can be when you have negatives. So I want to remind you that exponents only affect the thing that it is directly touching. So in part A, only 9 is being raised to the power of 2/3. The negative is not. It actually looks like this. So that means that you should simplify 9 to the power of 2/3, and then whatever that is, your answer will then be multiplied by -1. So I rewrote it as a radical, the cube root of 9 squared. I know 9 is 3 times 3, so thus makes this 3 times 3 times 3 times 3, and that allowed me to simplify. But here you can see that my answer is negative. Now in part B, you'll see that the 2/5 exponent affects the 32 and the negative. It's grouped. So that means that I can either rewrite it like this, the 5th root of -32 squared, and when I square the negative, it becomes positive. And then I know 32 is a perfect fifth. It's 2 to the power of 5. So I have that twice, so I get 4. Or if you rewrite it like this, I have the 5th root of -32, which is -2, but then I'm squaring it, which still makes my answer positive. So if I did not have parentheses around this, my answer would be negative. But since it is grouped, my answer becomes positive. So parentheses are really important, especially when you are dealing with negatives and you are working with exponents. So just be careful about that. All right, so today we're going to be covering a few different properties of radicals. So first we're going to talk about how can we multiply or divide radicals. So first, if we look at this product property, we can actually multiply two radicals as long as their index is the same. So notice both of these are nth root radicals. And if that's true, then you can simply multiply the insides, the radicands, together and place it inside a single radical. Likewise, you can also take a radical of a product and split it up into the product of two radicals if you'd like. But again, as long as the index is the same, you can multiply the radicands together to combine the two radicals. The same rule applies for quotients. So when you're dividing two radicals, you can do this. You can divide the radicands as long as the index is the same. So if you look at this example, these are both 4th roots. So you can rewrite it as a single radical of a quotient, and then you can actually divide 162 by 2. And then sometimes you're left with something that you should be able to simplify. All right, let's give this one a try together. For this first one, I have cube root of 12 times the cube root of 18. Since they are both cube roots, their index is the same, I can multiply those two terms, and it would look like this, 12 times 18. So I could do 12 times 18 and have a much larger number, but if I know I'm going to try to simplify, we want the factors. So I'm going to actually keep this as is and factor the individual terms, so it just saves me a little bit of time. So I know that 12 we can say is 4 times 3, so 2 times 2. So 2 times 2 times 3. And here we have 2 times 9 and then 3 times 3. So I'm going to list out my prime factors. I have 2 times 2 times 2 times 3 times 3 times 3. So you can see, oh, I have a group of 3 here, and I have another group of 3 here. So it leaves me with 2 times 3, which is 6. So that means, since there's no radical left over, that if we went back up here, if I had actually multiplied this out, 12 times 18 is 216, which turns out is a perfect cube. The cube root of 216 is 6, which means 6 cubed is 216. So again, especially if you're going to be simplifying something by hand, if something is already factored, I would not recommend multiplying it out. I would just keep factoring into the prime factors. All right, let's look at part B. Here we have the 4th root of 80 divided by the 4th root of 5. So both of those are 4th roots, which allows me to actually divide them. So I can do the 4th root of 80 divided by 5, and then I can do that division. 80 divided by 5 is 16. And if you do the prime factors, you'll find that 16 is actually a perfect fourth. It's 2 to the power of 4. So this simplifies to just 2, because you can see here that I have 4 powers of 2 for my prime factors. So again, this wouldn't be something, this term would not be something we can simplify. Cube root of 12, as is, we can't simplify. Cube root of 18, as is, we can't simplify. But if we multiply them together, we have a term that we can simplify. And then same idea for part B. Like 4th root of 5, we can't simplify that. But once we're able to divide it in, we get a number that we can simplify. So using these properties is going to be really important in helping us simplify. All right, so go ahead and pause the video and give these two a try on your own. All right, go ahead and check your work here. So for part A, I multiplied the radicand, so 4 times 128, but just to help me simplify, rather than expanding this out, I factored. And for 128, I got 2 times 64, and I know that 64 is 8 times 8, and I know that 8 is a perfect cube. So if you can try to divide by perfect cubes, it can save you some time. So here I have 2 times 2 times 2, so a group of 3, which gives me 2. And then I have an 8, cube root of 8 is 2, and the cube root of this 8 is 2. So we have 2 times 2 times 2, which gives me 8. And then for part B, I divided the radicands because they both had an index of 5. I get the 5th root of 32. This is a number you will see a lot. It's good to know that 32 is 2 to the power of 5, so you can recognize it and simplify straight to 2, or you can find the prime factors, which would be 2 to the power of 5. So either way, you'll get there, but it's good to start recognizing common, like perfect cubes, perfect fourths, perfect fifths, and it can save you some time when you're simplifying. All right, now we're going to talk about how to add or subtract radicals. So there's a couple things that have to be true in order for us to add or subtract radicals. First, the index has to be the same, just like when we're multiplying or dividing. But also, to add or subtract, the radicand has to be the same. And again, the radicand is the inside of that square root. So if these two things are true, then we're simply going to add or subtract the coefficients. So you're essentially saying, how many of this type of term do I have? And just remember, if you don't see an index, it's implied that that index is 2 and that it's a square root. All right, let's give a few of these a try together. So here I have the 4th root of 10 plus 7 times the 4th root of 10. So you'll notice that here I have 2 radicals where the index and the radicand are the same. So I'm simply going to add up the coefficients. Remember, if you don't see a coefficient, there's just one of them. So 1 plus 7 is 8. So I have 8 times the 4th root of 10. Okay, let's look at part B. So maybe you're looking at this and you're saying, well, this doesn't look like a radical, but remember, rational exponents are actually radicals. So let's rewrite this. The denominator of our rational exponent becomes our index. So we have 2 times the 5th root of 8 minus 10 times the 5th root of 8. So here we have 2 radicals that have the same index and radicand. They're both 5th root of 8. So I'm simply going to subtract their coefficients. 2 minus 10 is negative 8. So we have negative 8 times the 5th root of 8. So you can leave your answer like this, or maybe we can rewrite it. So we have negative 8 times 8 to the power of 1/5. You can also rewrite it back as a rational exponent. So either way is fine unless there's specific directions on how to write your final answer. So for part C, you're probably looking at this and you're saying, well, I can't subtract those two terms. this is the cube root of 54, this is the cube root of 2. And we were just talked about how the radicands also have to be the same. But sometimes you have a term that can be simplified first and then maybe added to the other term. So let's simplify the cube root of 54. So if I start finding the factors, we have 2 times 27, and 27 is another number to start recognizing. It is a perfect cube. It's 3 times 3 times 3. So if we simplify this, so we have 2 times 3 times 3 times 3. We have that group of 3, which we need for a cube root. So this simplifies to 3 times the cube root of 2. And then I still have minus the cube root of 2 from up above. So this doesn't look like it's the same term, but after you simplify it, we actually end up with the same index and radicand. So I know I can actually subtract them. So I'm going to do 3 minus 1, which gives me 2 times the cube root of 2. So again, sometimes you need to simplify before you can add or subtract, but you will come across sometimes where you just simply cannot combine the two terms because either the index is not the same or the radicand is not the same. All right, go ahead and pause the video and give these 3 a try on your own. All right, go ahead and check your work here. For part A, you have the same index and radicand, so you simply add up the coefficients. 1 plus 9 is 10. For part B, if you rewrite these as radical terms, you have the same index and radicand, so you add up the coefficients, giving you 11 times the cube root of 7. For part C, you need to simplify this radical expression first, but once you simplify, you do end up with 2 times the 4th root of 3. So you have a 4th root of 3 and a 4th root of 3. So I can actually subtract these. 2 minus 1 is 1. All right, the last thing we're going to talk about today is this idea of rationalizing the denominator. So in this class, we never want to leave radicals in our denominator for our final answer. We will say it's not fully simplified. So this process of clearing those the radicals in your denominator is called rationalizing. And depending on what is in your denominator, we might have to take a different approach. So there's 2 different approaches we're going to talk about. And one of them does involve multiplying by the conjugate, which hopefully is a word that sounds familiar. We talked about complex conjugates when we learned about complex numbers in the 2 chapters ago. All right, so let's give these a try. So here you could see that I have 2 over the square root of 5. So I have a radical in my denominator. We don't want to leave this for our final answer. So I know that for a square root, we need a pair of numbers. We would need 2 5s for it to simplify out. So I have 1 5 in my radical. I need 1 more to complete my radical. But you can't just multiply something to the denominator. You have to multiply the same thing to the numerator because anything divided by itself is 1. So we're essentially just multiplying by 1. So you can see now in my denominator, I have the square root of 5 times 5, which becomes just 5. So it clears the radical. And then in my numerator, I have 2 times the square root of 5. So my final answer is going to be 2 times the square root of 5 over 5. So again, this process of clearing that radical is called rationalizing. Now let's look at this next one. Here you could see I have a cube root of 5 in my denominator, which means I need a group of 3 to make the radical complete. So I'm going to multiply by the cube root. Well, let's see, I need 2 more powers of 5 for a cube root. Again, I have 1 power here. I need 2 more so I can simplify it. So I'm essentially multiplying by the cube root of 25. So in my denominator now, here I'd have the cube root of 5 times 5 times 5, which is just 5. And then in my numerator, I have negative 3 times the cube root of 25. So there you go. So you need to be careful. You're not just going to multiply by whatever you see in the denominator, because if you have an index that's bigger than 2, you have to ask yourself, well, how many powers do I have and how many more do I need to complete that group? All right, so now let's look at part C. So for part C, you can see that we actually have a regular number plus a radical. So when you have a scenario like this, this is where we're going to multiply by the conjugate. So remember, for the conjugate, you simply change the sign of your second term. So the conjugate of 5 plus square root of 3 is 5 minus square root of 3. But again, I can't just do something to the denominator. I need to multiply by the same thing in the numerator. So my numerator just becomes 5 minus square root of 3. And now let's start multiplying out the denominator and see what happens. 5 times 5 is 25. And then I have 5 times negative root 3, so negative 5 root 3. And then here I have root 3 times positive 5, so plus 5 root 3. And then here I have positive root 3 times negative root 3, which gives me negative square root of 9, which will become 3. So I'm going to simplify in this last step. So the conjugate is great because look what happens with our middle terms. They should always cancel out if you multiplied correctly and if your conjugate is correct. So those will cancel out. So we have 5 minus root 3 still in the numerator. And in the denominator, we just have 25 minus 3. So you can see that now my radicals in the denominator are gone. So we have just rationalized the denominator. So again, the process for this is either completing the group in your radical, so multiplying by however many powers you're missing, or if you have a denominator that's a whole number plus or minus a radical, you're going to multiply by the conjugate. And always make sure you're doing the same thing. You're multiplying by the same thing in the numerator and denominator. All right, here's the last one for you to try on your own, so please pause the video and give it a shot. All right, go ahead and check your work here. So for part A, you need to multiply by root 7 over root 7 to complete the square root in your denominator. So that will turn into square root of 49, which is just 7. For part B, you have 1 power of 3, but I need 4 because the index is 4. So I need 3 more powers of 3. So I'm going to multiply by the 4th root of 27 to the numerator and denominator, and you end up with this. And for part C, I multiply by the conjugate. So again, for the conjugate, you just change the second sign. It doesn't matter if the integer comes first or the radical, just change the second sign. So it went from negative 2 to positive 2. When you multiply it out, the middle terms cancel out and you end up with the square root of 49, which is just 7. So your radicals disappear. All right, that's all for today's video. Thank you so much for watching.